Assalamualaikum and welcome to SSD. So LTspice users, you may have some problem with capacitor and inductor's initial condition. I mean, if you want to find the voltage across this capacitor, you see the voltage across this capacitor is directly starts from 12 volt. But what do you want? The initial condition is 0 volt and it will gradually 0, then 1, then 2. I mean, exponentially it will go to 12 volt, but no, it's not happening. Similar things happen here. If you try to draw the current of this inductor, you see the current is directly minus 12 milliampere. But what do you want? The initial current is 0 ampere, then 0, 1, 2, 3, then minus 12 milliampere, right? So in this video we will solve this problem. So what is the problem actually? The problem is, if you want to find the voltage across this capacitor, you see it directly starts from 12 volts. That means the simulation is starting its analysis from the final condition or steady state condition, but no, you don't want that. You have to set the initial conditions. So in this video we will not force this node voltage to 12 or 10. We will do it efficiently. Okay, so let's start. Press control and then right click on the capacitor. What I have done, press control then right click of the mouse on this capacitor. So you have obtained a component attribute editor. Now space line 2, just simply write here IC is equal to 0. Okay, so see you have IC is equal to 0. Now run the simulation and see the capacitor's voltage is from 0 to 12 volt, right? Let's change this IC. Just right click here and change that to IC is equal to 2. Now press the run the simulation and you see the voltage starts from 2 to 12 exponentially, right? Okay, here you may have some problem with the polarity of this capacitor. Okay, so how can I understand that the polarity, the positive polarity is here and the negative polarity of this capacitor is here? This is by, if you put your mouse here, you see the current direction is from left to right. That means this is our positive and this is our negative polarity of this capacitor. So if I change the capacitor, let's say if I rotate this, now if you put the cursor here, you see the current position has been changed. And if you run this simulation, you see the capacitor's voltage starts from minus 2 volt. So please don't confuse with the polarity of this capacitor. Just remind that if you put your cursor on the capacitor, so the current is from right to left. That means right is the positive polarity and left is the negative polarity. So now let's go to the inductor. Okay, so inductor current is directly minus 12 milliampere. Simply right control, then right click, press control, then right click on the inductor, then space line IC is equal to 0. Okay, now let's decrease this to 10 microsecond to visualize it. Now press the simulation and you see from 0 milliampere to minus 12 milliampere. Again the inductor's polarity, you see the initial current is directed to the leftward. Let's rotate this inductor. Okay, now the inductor current is to the right. Run the simulation and you see the current is from 0 to positive 12 milliampere. And if you change the current, let's say it's 2 milliampere, let's see what happens. Oh sorry, let's say it's 2 milliampere. See the current starts from 2 milliampere to 12 milliampere. So in this way you can change the inductor and capacitor's initial condition.